complicated or blissfully simple, depending on how you want to look at it. So we've got with us today Alastair Walker from Lorit Consultancy, and he's going to talk to us about ISO26262. So, Alastair, welcome to the show.
Thanks very much. Hello, Ryan.
Could we just start, Alastair, by talking about your background and where you're from and how you got into doing this?
Sure, no problem at all. I'm based between two camps. One is in Edinburgh in Scotland, and the other one is Salzburg in Austria. Background is as a development engineer, so very much in embedded systems, hardware predominantly in the early days, but I did a lot of embedded software as well, C, C++. This was over about 25 years, and like a lot of people, as your career progresses, you get into more and more paperwork, more and more standards, and less hands-on development.
Yeah.
So by the 25-year point, I was moving back from Austria back to Edinburgh, and I had the choice: do I work for another company or do I set up my own business? So in March 2014, we set up Lorit Consultancy, and the model is very much supporting companies in safety-related industries with embedded activities. That is hardware, software, and systems reviews, support, matrix, etc.
Right. And what drew you across to functional safety? What was the lead into that? Because it's a pretty specialist area.
Sure. I mean, basically, I spent about 14 years working in the medical device sector. So with moderately dangerous products, nothing at the sharp end.
Literally.
Yes. Yeah. I then moved to the aviation industry. And the last role I had as a developer was in the automotive sector. So basically across three different industries, seeing how the different industries apply these kinds of standards became quite an interesting area for me. And this is the kind of model. And since setting up Lorit Consultancy, we actually work in multiple industries. And a lot of our business model is actually comparing techniques and strategies in one industry to another.
Oh, right. Okay. Fascinating. So then if we jump straight into the kind of the big topic, because I guess 2014, 26262 is well kind of underway by that point. So it's a... I don't even know where we start. Where do we start? What is ISO 26262? There you go. I'll put that one out there.
Yeah. No, it's good. It's a very good starting point. It is a functional safety standard aimed at on-road vehicles. And as you mentioned there, the first version of it came out in 2011. And at that point, it was very much focused at cars under 3,500 kilograms.
Yeah.
The second version came out in 2018, and they added buses and trucks and motorcycles into the mix as well. So it is a electronic and electrical safety standard, very much aimed at these aspects, so embedded systems, hardware, software, etc. And the whole map takes you through, from an OEM's perspective, looking at hazard analysis, risk assessments, to look at vehicle level, what the hazards are, and how controllable these hazards are. And as ISO 262 progresses, you then take those first hazard analysis and risk assessment outcomes to define what they refer to as an ASIL level, an automotive safety integrity level, and then you have different levels assigned based on the criticality of the given item or element used in a vehicle.
All right. And what do you think, going back to the beginning, what's the problem that they were trying to solve by bringing a standard like this in?
They basically had a standard prior to this. There's IEC 61508, which is often referred to as the mother of all safety standards. Many safety standards have come from this, but there was a general feeling that it wasn't specific enough for the automotive industry and for the changing automotive industry. So 26262 was produced from that, but there are still a lot of similarities there. But to answer your point, I mean, ultimately you're developing very complex electronic systems. There are random failures that you would experience in hardware. There are systematic failures that you would experience in software, hardware, or systems. And you've got to manage this. There's an ever-increasing amount of electronics then being deployed in vehicles. You know, you can be talking about hundreds of processors now in cars.
Yeah.
So how they interact with each other, how you control each aspect becomes a very challenging activity indeed. And the drive to get 26262 out was to try and meet this ever accelerating change in the landscape for vehicles.
And now kind of powertrains are progressing to more electric powertrain and hybrid powertrain. Does that, you know, make 26262 even more important? Do you see a sort of a shift on that side?
I think it's an important standard without a shadow of doubt. It was when it came out in 2011. I think powertrains are one aspect, but when you start looking at things like autonomous driving, that's basically a big topic at the moment.
Yeah.
You've also got topics like cybersecurity. You have additional standards that then are going to link into 26262 to cover this whole landscape. It's a very complex area, and I don't think too much has changed in the last few years necessarily in terms of things like drivetrains.
Yeah.
But there are more and more electrified components in vehicles, and 26262 has to cover all of these new things. One area there's been a big drive in, and I should stop using the term drive, of late, battery management systems, lithium-ion batteries, and the dangers associated with these types of components. So, you've then got to be able to address some of the challenges around things like that. So, always changing, always shifting, and, we've done quite a lot of work with semiconductor suppliers in ISO 26262, and the number of different locations that microcontrollers and sensors are used within vehicles. The applications, the number of applications is just risen exponentially. So you have to deal with all kinds of different scenarios.
Yeah, okay. So I guess it's clear 26262 is really important from a vehicle development, component development level. And essentially, if I had to summarize it in a nutshell, it's a standard to make sure that the electronic hardware and software that's being implemented in every aspect of the vehicle all works properly, doesn't have any unintended consequences, and delivers a safe and stable product for the user. Is that in a nutshell?
That's a good way of putting it in a nutshell. Yes.
Okay.
Yeah.
So then, how do you go about implementing that in the development cycle? Where do you start?
Sure. Well, I mean, if we look at the starting point, one of the key factors in the whole development cycle of automotive components is often you can be looking at a tiered structure. So you may have OEMs, you may have tier 1 suppliers, tier 2 suppliers, and the interfaces between them. So starting off, as we mentioned a little bit earlier on, you have at an OEM level, a vehicle manufacturer's level, this hazard analysis and risk assessment.
Yeah.
You then define the different ASILs for the items you're developing. You then continue this activity at a functional level. So there's what's referred to as a functional safety concept. This is not yet focused on the implementation, but is looking at risks at a functional level. Then you move into a technical safety concept, which is then starting to map out how it's going to be implemented, whether it's in hardware, whether it's in software. And then you move through the process there. You have a variety of different safety analysis. For hardware, you have hardware matrix to fulfill. Software, you've got various matrices, you have various methods and techniques. It goes further as well. It then comes out the other end of that whole journey. And a lot of the focus is about how you're going to implement it in production. And one of the key things is if there are specific risks found in the hardware development activity that would require additional measures to be applied in production, that is all linked into it as well. And then around about it, there's a good definition of the additional supporting activities, verification activities that are required. We talked about safety analysis. If you're decomposing your architecture to split it up into smaller bits, that you have proven that there is freedom from interference between decomposed blocks. So as a standard, it is very good. It's very prescriptive. It is quite a lengthy read with 12 parts. But as mentioned, we work in some different industries, and not all industries have as good a safety standard as 26262.
Yeah, it's. I mean, there's some interesting sort of stages in the process where, like, we can see at an early stage, like I've seen this. It becomes almost a bit of a black hole if you get that the early step, that first step wrong, and essentially go kind of too deep in terms of the level of detail when you're looking at doing the hazard assessment and the functional risk work. You just kind of end up getting lost at a very early stage. So is there a way of kind of managing that to make sure you don't go down a black hole? And I think that's because a lot of people who 26262 can be a bit of a scary thing for people. You know, they're kind of, if you mention it in a room full of engineers, there'll be a lot of sharp intakes of breath. Some people might even leave the room, and it's kind of seen as being a bit of a scary monster of a thing. So how do we avoid those the pitfalls of getting sucked down a rabbit hole at an early stage?
I think the one piece of advice here is to remain pragmatic. You know, as you say, some people can start getting drawn into fine details in specific areas, but you want to look at particularly issues at a systematic level. And that's a very useful tip. One of the black holes you just referred to there is often people get drawn into this whole activity of hardware matrix, looking at failure and time rates and so on. But taking a systematic view to look at what could potentially fail in a system without delving down too far, getting that overview, and then digging into the things you need to dig into as you progress. FMEAs can be a very good approach. System FMEA, looking at what potential failure modes you might have at a high level, and then only drilling down into the areas you need to, rather than kind of running around like a rabbit in the headlights trying to deal with everything at once.
Yeah, so it can be where you've got, you know, it's the norm in the automotive industry for components to be used on lots of different vehicles. So you might develop a component, and that's used by, I mean, even one manufacturer on 4 different models, for example, or you might have the same component that's used by 5 or 6 different manufacturers and developed somewhat in isolation from the vehicle. And in those kind of cases where the component is in its standalone environment, then I think it also becomes difficult knowing what the boundary condition looks like around the component. So
that's a very good point, because I mean, one of the elements of ISO 26262 is the whole story about safety element out of context. So you are developing something without knowing 100% the end application it's going to be implemented in. And this then leads to the whole activity of defining assumed requirements. So you're saying our product will do X, Y, and Z, provided that the product it's integrated in does the following A, B, C, or whatever. So it's also quite a challenging activity because you're asking people then to best guess what is going to happen in the environment outside the thing they are developing, but then communicate that to whoever is integrating your given product. And then, in theory, the purpose behind that is they could challenge your assumptions, which may lead to a modification of your safety element out of context.
So you end up effectively with these kind of quite extensive documents outlining all the assumptions that you took.
Yep. I mean, when you look at the likes of the microcontroller manufacturers, they will produce a safety manual that could well have several hundred assumptions. So the assumed requirements, it will work properly if you do X, Y, and Z. So mapping those out, and whoever is integrating that into their system then has to make sure that they have followed all the assumptions or potentially challenge them if they need to.
Yeah, that's a really, really valuable kind of way of looking at it, because I think oftentimes some people will try and effectively answer every possible scenario. So when they're doing that out of context, the black hole that you can get sucked into there is, rather than being quite systematic in terms of your assumptions and taking a kind of pragmatic view of how this should behave, you effectively get drawn into, well, because I don't know what it's going into, I'm going to make it do everything that I can possibly think of. And that adds cost to the component and adds time and complexity to the process.
Absolutely. There's an interesting point there as well, because like a lot of safety standards, you can exercise state of the art. You can use the best known development processes at any given time. And 26262 does encourage you to do that. But one of the natural things that a lot of people fall back into is following a standard to the letter of the law.
Yeah.
So they will only follow the clauses that are defined in a standard. But 26262 does encourage you, if you have a better solution and you can justify it, then by all means use it. So that's often an important way of avoiding getting sucked into these black holes as well that you were referring to.
Yeah. I had it was an interesting one the other day where I was talking to someone, and so they were talking about sort of 26262 and need for kind of redundant systems, and I can't remember exactly how we got on. You can tell that the quality of my kind of beer conversations is right up there. Functional safety system redundancy, and I said, well, you don't ever have, for example, two B positive connections to a power inverter. And the person I was talking to was saying, actually, well, you should. And I said, well, but really, you don't have two batteries in an electric vehicle. I'm thinking electric vehicle here. So you don't have a redundant battery system in an electric vehicle. So, where do you stop from a practical point of view? And again, this person was kind of, well, nope, you should. So he thought in the future we would start to see electric vehicles with two batteries in order to give that sort of functional safety. And I said, no, I can't ever see that happening. That'd just be way too much cost and complexity, and it probably adds more problems than it solves. But where would you sit on that kind of thing? So there are these points in the system where you've got potential single point failures. So what's your view on that? Do you think we'll have two batteries, or
No, I'm very much in the same boat as yourself there. I mean, drivetrains, I'm glad you mentioned those at the beginning, because that's another classic example. Now, if you're going to have H bridges with IGBTs, multiple transformers, multiple drives on motors or whatever, the cost is going to go up exponentially. So there has been a move to have fail operational rather than fail safe for things like microcontrollers and so on. That's fine. You could lose a core, it still keeps driving. But if you're talking about having redundant motor drive systems, some drivetrains, as you know yourself, you'll have things that are switching hundreds of amps through large motor drives. the cost of the motor itself. So there is a practical point where you say, yes, we can have as much redundancy, but ultimately you come back to one single point. And that's often very much around power supplies as well. You can have all kinds of redundant power supplies in a system, but eventually it all comes back to one point where you often need a fuse because you've come back to the one primary source that's supplying the product. So
yeah.
Ultimately, there is always going to be a weak link, but obviously what you're aiming to do is to reduce the probability of that one event that would take the system out. So throwing as many redundant parallel systems at it is not the answer.
Yeah.
And it's also a technique. There's a very famous gentleman, Alessandro Birolini, who wrote a very famous reliability engineering book. And that's his advice as well. You're not going to solve problems by trying to lay down as many redundant paths as possible. It's about good design, good interfacing, and good systematic approaches.
So, and would you say, because I think that is probably one of the things I hear when people talk about ISO 26262 a lot, and I always think that's a bit of a myth. So if we're going to do a bit of myth busting today, would you say that is a myth that ISO 26262 requires you to have redundancy in every system?
Yeah, I would say it doesn't encourage you to have redundancy in every system, but it does encourage you to systematically analyse what could fail and how you can mitigate it. Now, one approach is to have a very robust component. So if you have a component that can satisfy ASIL D, then you are saying this is something that has a low probability of failure, and we are happy enough that this one component, I mean, you look at things like Hall sensors, that's a classic there. A single component, critical role maybe in measuring speed, whether it's in a wheel, braking system or whatever. But ultimately, you don't want to be putting 2 Hall sensors down for everything you do, or you'll be, as you say, put the cost up exponentially.
Yeah, yeah. Okay, so redundancy, I'm going to try and put that in a nutshell again. So what we're saying is redundancy in every system isn't essential, but a systematic approach to identifying the failure modes is. And redundancy might be appropriate, but it also might not, depending on what that system is and what the kind of likely failure hoods are. Is there a kind of way of establishing what the threshold is in terms of how do you know if something is robust enough that you could achieve ACE or D without having redundancy there? Are there systematic ways of identifying that, or is it kind of up to good judgment on the part of the development people?
No, I mean, there are systematic approaches. Yes, good judgment on the part of the development team. There are systematic approaches you can absolutely follow. The whole topic of redundancy we're talking about there as well, redundancy on its own often isn't that helpful. It's diversity in your redundancy that is important as well. So
explain that a little bit more. What does that mean?
Yeah. I mean, if you put the same component down as a redundant mechanism for your primary component, then what is the probability that that same component would fail for the same reason? It's back to your dependent failures analysis, the common cause failure scenarios.
Okay, that's interesting because actually, I think one of the trends that I've probably seen is people go away from. So in the past, it used to be quite common to have like a microprocessor and then some sort of alternate like watchdog system sitting on the side of it. So it was a different component set. Oftentimes much simpler componentry. So you micro, and then you watchdog circuitry to if there was an issue, it either reset it or flagged it or shut it down. But then there's been a kind of a big move away from systems like that to just these sort of straightforward dual core kind of processors where it is 2 identical cores side by side on the so it's
there are still a number of options, particularly from the larger microcontroller manufacturers. As you say, they may have multi-core processors, but they often offer watchdog chips that will actually monitor the program flow within the main processor as well. So a much smaller partner device, but will be checking the homework of the main processor. But if you have one block of silicon, obviously that one block of silicon can fail for whatever reason. Have you got a way of ensuring that your system achieves its safe state? So this is the point, that it doesn't always have to just be redundant mechanisms, provided that you can prove the failure modes of your product, what they are, and how they can be mitigated. Then there are ways that doesn't always have to require having a redundant path.
Wow. So there's a huge depth to this. And just sort of thinking about, various vehicle launches that are going on at the moment, and actually quite a high profile one where they have effectively they've declared their hand in terms of, Volkswagen have said with their new car, the new electric, the ID3, that, we have delays because of issues in terms of getting the software right. And we've heard that before. There's been sort of delays and reported issues with other programs. I think initially, when Tesla were trying to ramp up, people were very critical of them in terms of their approach, and maybe the other OEMs kind of finding that there's a lot to it now. But where do you see so that things like the issues at Volkswagen is that? Do you think that is probably to do with functional safety and getting these kind of things right in testing? So presumably they did all the functional safety work earlier on in the process, and they'll have FMEA'd, and now they'll be at a stage where they're just testing to see how it all works and how devices bounce off each other. What's your take on that?
Yeah, it's an interesting point, and it's also an interesting point that a lot of prominent people in the world of functional safety, and we've recently been including some slides from Nancy Levison in training courses of ours, basically, who will say, well, almost all problems go back to requirements. So if you have not captured your requirements, you do not have the proper traceability down the levels and across to test cases, then this is often where a lot of problems come. Defining requirements up front, knowing what you're trying to achieve, but that also goes hand in hand with a changing world nowadays. Most software teams that we work with want to work in an agile approach. And that is a major challenge in itself, making sure that you have captured safety requirements properly, but still allowing people to use agile software techniques.
Okay. So let's just, because I had a question for you, which was how compatible is agile software development with 26262? So how, let's dig a little bit more on that. So in terms of, in terms of that, how do you make an agile process kind of tie up with 26262? Is it possible?
Possible, yeah, absolutely. I mean, 26262 has a statement that says you cannot compromise requirements, documentation, and rigor, which is quite right. But good agile teams can absolutely work within that environment, producing safe products, managing requirements properly, but still doing it in an agile within an agile framework. Obviously, the key aspect is for people who are used to continuous deployment and so on, where you're just basically shipping software out without the rigor, that doesn't fit with a safety environment. But making it as efficient as possible, you go round and round the loop, round the backlog as many times as you like, you baseline, you ensure that baseline ticks all the boxes for the safety activities, then off you go. So it's a hybrid, it's in between the two, but it is absolutely possible, and that's a way a lot of teams, particularly software teams, work nowadays.
Right. And so another question, because in another way, and I mean, you already mentioned yourself that you work across industries, so you're in aerospace and med tech and automotive, and a lot of companies doing product development are also supplying different industries. So it might be on highway, and as simple as on highway and off highway, where you don't necessarily need ISO 26262 in everything. So that's another myth that I hear quite a lot is around whether you have to have business level systems, or actually you can have a project level, a project operating to the standard within a business where the whole organization isn't necessarily operating to the standard. I know it's a difficult one, but how would you go about unpicking that? So in terms of what are you accrediting with 26262? Is it the business or the process or the product? And how would you manage that in an organization that serves lots of markets?
Yeah, I mean, it's in all these instances, it's always down to use cases. So you can have a company that's developing products that are safety relevant, products are not, but they have to, based on the use case, apply the appropriate level of rigor and methods to ensure that they can meet that particular standard that is relevant at the time. So you don't want to go over the top. If products are not going to be required to comply with something like ISO 26262, then you can strip back the processes and the activities to fit accordingly. But this is also a part of ISO 26262. It talks about tailoring of projects. So as an organization, you want to be able to adapt the rigor and the methods appropriately for the type of project you're developing.
Yeah. Okay. And is that the end? So in terms of what you guys do as a business, where are you kind of focused? Are you helping companies at that sort of organizational level, or are you getting into the kind of nitty gritty of the kind of product functionality? Where is Lorit fitting in?
A bit of both. I mean, we work with people, often a lot of companies who have never worked with 26262 before. Then you take them through the whole framework. Then we also get involved with certain companies that are very experienced in 2626262, and you effectively can become part of the team working on given activities. It might be just hardware or software activities. So as a consultancy, it varies really from customer to customer, but the ones where we get involved in a much wider field of application is generally with small companies. Right. Larger companies, they already have processes, infrastructure in place, and they want you to carry out really maybe only one or two specific activities. So varies very much from company to company.
Right. Okay. And as a business, you mentioned earlier you've got two offices, the one in the UK and one in Austria. Is there a sort of difference in terms of the focus of the two offices? Do you service different markets and that kind of thing, or?
I mean, probably more. I would say from the office in Salzburg, it's automotive. So right. 26262. We do 26262 business here as well, but we tend to have a lot more medical device customers. So right. Two predominant industries that we're involved in. And obviously, the automotive sector has certain hubs where it's hotbeds of automotive, while the medical device sector seems to...
Edinburgh not being known as being a hotbed of automotive. But...
No, definitely not.
Yeah.
So medical device development tends to be spread across the globe, so in every corner. So it depends very much. But automotive is, particularly with Salzburg being only an hour and a half from Munich. One of the big hotbeds of automotive is Munich.
Yeah.
There's a lot of suppliers, big suppliers in Austria as well, who supply OEMs. So.
Right. And so in the different markets, you've got in medical, for example, how does that compare? So I think a lot of people in automotive would be interested in terms of knowing what other sectors do and how 26262 compares. Is it overkill, or is it actually a kind of benchmark standard that other sectors would look to?
Very much a fan of ISO 26262. I think it has the right approach.
Yeah.
It does have a series of tables that are then based on the classification and the methods that should be applied. And I know some people can be a bit critical of that it's a bit restrictive. But in comparison to the medical device sector, it gives you far more guidance. And if you look in the direction of aviation standards, then they don't even call themselves standards, they call themselves guidance documents, because nobody wants to be in front of a judge if the plane comes down. So, and they are very high level indeed. So there are some significant differences between the different industries.
Right.
26262, I would say, is pretty good as a standard. It does give good guidance.
So how would that work then in the aerospace industry? Is it much more down to the individual companies to kind of define their requirements and push it back through their supply chain, or?
It's down to individual companies.
Yeah.
The standards, if you look at the hardware standard DO 254, software standard DO 178C, they are very much written at a high level.
Right.
So the actual implementation detail is down to the individual organizations. But the other advantage, in theory, if you want to call it that, if you want to release anything in the aviation industry, it has to go to one of the organizations like EASA or the RTCA, and they go through everything with a fine-tooth comb, and it's only on their say-so that you can launch the product.
Okay. So there's probably more independent sort of verification of the work.
Absolutely. Now, in the automotive industry, this can be functional safety managers in different, at the OEM level, tier 1, tier 2, and then approval via these functional safety managers.
Yeah.
So it's not a case of sending it off to some kind of god in some other city who then approves it for you. So that adds that's a little bit more rigor in the automotive industry as well.
Right. I guess, I mean, it's always the case in automotive. I mean, it's sort of a double-edged sword, but the OEMs realized a good few years ago that everybody having their own different playbook wasn't helpful because they were effectively introducing new costs, every time. They couldn't, in the supply chain, couldn't develop a component that was going to work for every OEM if every OEM had completely different standards. And to certain degrees, OEMs have kind of brought in things like 16949, where they've kind of harmonized around a quality standard, and 26262, where they've harmonized around functional safety methods of working. And I guess the objective is to try and stop you from then having to have 12 different standards that you work to, which is probably less of an issue in aerospace, where you've only really got 3 or 4 big OEMs.
Yeah, absolutely. Yeah, I mean, as you say, you really want to achieve standardization. You don't want to have everybody coming up with different solutions, and this is often where a lot of problems come from. Is basically different approaches, different solutions. As you said, there, 16949, the quality management system standard in the automotive industry, is also a very good document and gives very good guidance to teams in terms of implementing quality management.
Yep.
I mean, one of the things that's actually good is that organizations like the VDA and the AIAG will even define scoring systems for things like FMEAs. So there is even standardization across the severity, controllability, occurrence rating of things like FMEAs. And some other industries, you don't find that. It's entirely open to interpretation by the teams involved.
Yeah, I have seen that before, actually, in the off-highway industry. Some people use different numbering or rating systems, and that has caused a little bit of confusion to me. Anyway, I find it hard to get with these things at the best of times.
Yeah, I know the issue.
Yeah. Is it, so then medical devices, medical technology, it seems like there could be, because, unlike aerospace, there are lots and lots of OEMs in medical devices. It's still, it's critical to life. So you're developing stuff that if it goes wrong, people are going to die, although not hundreds not hundreds at one time, probably. But from a medical device point of view, what's the approach there? How does that work?
It is very much risk-based as well. I mean, it has its own dedicated risk management standard, ISO 14971. One of the problems of the medical device industry is that the bandwidth of products is huge. So you could be talking quite innocuous things to devices used in intensive care units, dialysis machines, things that are extremely dangerous. So it's very difficult to find a set of standards that are going to address every type of product that comes into the medical device sector.
Yeah.
So very open, and the way they're often written is open to a lot of interpretation, and that's one of the problems there. So this is why I was saying that 26262, maybe because the scope is narrower, but it is certainly a better standard.
Right. And it seemed like it was an issue with the coronavirus thing, when everyone was kind of rushing around trying to build ventilators and equipment. There was quite a bit of an issue there in terms of certifying and standards for the new products that had been developed. Particularly, what came out was that, different equipment manufacturers have different standards that they work to, but different. Effectively, the customer, the sort of your NHS or your equivalent kind of health organisation, have different standards that they require. So someone making a ventilator might make a different specification product from one health organisation to the next, depending on what their standards were.
Yep.
And it just adds cost and complexity and makes it hard to scale up production and respond to system.
It's an interesting point there, because in the medical device sector, there are predominantly two camps. There is the CE marking route through the EU, or there is the FDA in America. They don't always have the same view on specific products and specific risks. So if you are going to develop a product that's going to be sold globally, you're going to have to make sure you tick the boxes for both parties, ideally before you start developing it.
Yeah. Yeah, and we have that issue in automotive to certain standard, because we're not quite harmonised yet on standards from the US to Europe to other territories. But it does feel like it's getting there, in terms of global standards harmonisation. I know it's a bone of contention with the US. The current president wants to be able to sell products in Europe, particularly, that doesn't meet European safety standards. And that's resulted in quite a lot of political fighting.
Yeah. No, we want to move down the road where we have a standardized development process in every industry. But as you say, we are moving in the right direction, but sometimes these things take a lot longer than you would hope.
Yeah. So we'll get back on. That was really interesting. Thank you. So back into automotive world. Do you think are there good tools that can be used to help with the implementation of 26262? Obviously, quality training from an organisation such as Lorit will be a good starting point.
Yes.
But are there also kind of tips and sort of are there tools that can kind of automate parts of the process that you can implement in the business?
Absolutely. In all areas. We talked about requirement capture, very important part of the whole process. There are lots of requirement capture tools. You often get a lot of different opinions on them, but there are certainly lots of good tools. When you're talking about analysis, lots of people who produce, really good quality fault tree tools, FMEA tools, etc. If you're talking about the verification side of it, lots of people producing good hardware in the loop, processor in the loop tools, again, and tools for automating test. We talked about sort of agile approaches earlier on. There are a lot of people produce good continuous integration tools. So certainly across the automotive sector, there are a lot of people producing good suites of tools now. And it's also one of the things that's quite a key challenge in the automotive sector is the whole topic of tool qualification. So if you purchase a tool, how do you know you can trust that that tool will deliver what you think it's delivering?
Yeah.
But most of the suppliers now, I mean, most compiler manufacturers, many of the tool manufacturers will then have a certified tool that will meet ASIL D, and gives you that reassurance, not only that you like the tool in terms of its functionality, but it gives you the reassurance that the tool is not going to do something you don't expect.
Because I know, in the early days, it was a really big problem when you were trying to do 26262 projects that actually there weren't tools that automated the process. So everything was kind of longhand, and you were very dependent on the engineers doing the work and their sort of ability to navigate the standards. I think the kind of headline figure of almost any component, it would add £1 million to the process. So £1 million, $1.5 million, something like that, of extra engineering costs to do 26262. And I think the first time I met you, I think you were doing a presentation about 262, as you do, and it was fascinating. But you were talking around that and how that kind of how that had changed in terms of the additional cost that it doesn't necessarily need to add to a process.
I mean, it is now, as you say, there are many standard components that are sold compliant with a certain ASIL level in 26262. There are many tools now that are qualified. Yeah. So yes, it does add extra time, extra cost to projects, but that is reducing. It's not as it was in the early days where basically you didn't have qualified components, you didn't have off-the-shelf components meeting certain ASIL levels. Now you do, so it makes the whole activity easier. And because so many people have been working on this really since 2010, 2011, when it first came out, that there's been a significant time there for people to catch up and start producing compliant suites and compliant tools for the industry.
So I know this is probably a how long is a piece of string kind of question, but what would you say a development cycle, what the difference would be for a product between a non-26262 development cycle and a 26262 development cycle? Do you think, is there a way you can kind of quantify that in terms of what it should look like, or have I just asked a really terrible question?
No, there's an element of how long is a piece of string, but for some projects you may be talking, say, 50% additional effort. I think what would vary there as well is if you're already geared up for ISO 26262 and have been doing it for some time, and somebody asks you to produce a non-ISO 26262, you wouldn't have an issue with that. You could do it. You would cut out some of the rigor and produce the product.
Yeah.
If somebody comes along to you and says, you've never used ISO 26262, now we'd like you to develop a product. There's the whole massive learning curve and the time to get up to speed, understand it, and then probably encounter some of the pitfalls along the road. So varies depending on which perspective you're looking at. But if you are well au fait with ISO 26262, you might be ballpark figure talking about maybe 50% additional effort in comparison to a non-ISO 262, but that's finger in the air, right. Kind of.
It's still significant then. So be a significant additional layer of work to add to the development process.
Yep. I mean, you consider the number of work products that are defined in ISO 26262, you would be writing many of those anyway for any other project, but would anybody ask you to apply hardware matrix processes to a normal project? And that is quite a time-consuming activity. Whether you would have to do fault trees for the whole system or not, for an on-circulated product, again, that's the kind of aspect that adds to the workload in these types of projects.
Yeah, it's a huge topic, and really, because people quite often will pick up consumer electronics, for example. You look at an iPhone or a laptop computer and go, well, that's a lot of technology for not a lot of cost compared to what the same thing in an automotive environment would cost. But I guess it's an unseen additional kind of overhead for the automotive market of all that additional safety standards and sort of the whole, I was going to say verification, but it's the whole development cycle is done to a much more rigorous level and just takes more time and adds more cost to the product.
Yeah, no, absolutely. But as mentioned, if you are already geared up for this, you've been applying it over many projects, then that difference would certainly be smaller.
Yeah.
But, I suppose one of the questions is how many people who are developing ISO 26262 projects are asked to do non-safety related projects. So it's maybe not a crossover that happens that often, but it will happen with certain companies.
Yeah, no, for sure. One of the areas that I see, I don't know, it sort of concerns me a little bit, but there's a lot of people out in the market at the moment who are starting to look at EV conversions. So it kind of seems like a really nice thing to do. And we get approached all the time, companies who want to buy powertrain components from us or have us help them doing EV conversions. And we always sort of basically, with only a couple of exceptions where companies are doing it right in terms of the engineering work, we always end up having to kind of gracefully say no. But it does concern me where companies are doing things like taking a Nissan Leaf powertrain or a Tesla powertrain, and they're basically using the kind of basic components like the motor and some of the power switching device and such like, but they're taking the control cards out and replacing them with aftermarket control cards that just it's like a world of potential pain in terms of all of that hard work that was done on 26262 compliance being kind of thrown away. And I think it's probably all right if you're doing it at a hobby level, but companies now doing this sort of thing, I think there's asking for trouble really not, be very, very difficult to do that. But I'm not sure, because with 26262 it probably wouldn't apply. So it applies if you're selling a new road vehicle. But I don't know, do you know, does it apply if you're making a significant modification to a road vehicle? I guess it probably doesn't.
No, it's for development processes. So obviously there is legislation in every country or every continent to ensure that products are still safe, various directives. So you need to then still ensure that you're meeting directives in any market. But it is for new development as such, rather than just servicing.
Yeah, the sort of replacement, and I think it's as more and more EVs are on the road, there's going to be more of these components, and EV gets crashed in a wreck, and then the powertrain's there. So why not find a good way of recycling it and using it for something good? But it's definitely something people have to be super, super careful of, that they're implementing it correctly and safely, and not kind of overlooking the thousands of hours of man effort that have gone into creating these complex control environments that are very safe and stable.
Yep, no, absolutely.
So just checking the time, we've gone over. So I thought we had. I put my sound recording deck is in a slightly different position. I can't see the clock on it, so I keep sort of craning my neck to look at. So we've run over time, so I apologise for that. One last question. So just in terms of your business and looking forward to the future, what are you most excited about in terms of what you guys are going to be doing in the next year or so?
We've been involved in a number of really interesting and quite novel projects of late. We've taken a few sort of diversions into some quite interesting areas. So keeping going, we are an international business, and as I say, that customer base has grown, not just in terms of numbers, but locations. So we want to keep that going and keep the interesting projects coming on board.
Oh, brilliant. Okay. So if people are interested, I will put links to the Lorit website and to Alastair's LinkedIn profile into the show notes. So if you want to get in contact with Alastair and find out more about what he could do to help you with functional safety and with 26262, go down to the show notes and have a look there. But that's been absolutely fantastic. Alastair, thank you very much for agreeing to come on the show.
Thank you very much, Ryan. Very good. We really enjoyed it. Thank you.
So I hope you enjoyed that as much as I did. I learned so much from talking to Alastair there. ISO 26262 is a huge topic. It's really essential to powertrain development, to automotive development. It's a massive part of developing any kind of system or component for on-highway use in the mainstream automotive industry. So if it's something you're interested in, like I said, I'll put Alastair's details below. Do check him out. He's an absolutely fantastic guy, and as you can see, he really knows his stuff. That is all we've got time for today. We do have some fantastic episodes coming, so don't forget to subscribe, leave us a rating, a comment. We will get back to comments as much as we can. Some great comments come recently. We've had some really good conversations going with people online through some of the different forums where we can actually feedback. So that's fantastic. And if you've got any questions that you'd like us to look at as well, don't be shy. Send your questions in and we'll take a look and see if we can answer those too. That's all we've got time for today. I'm really looking forward to speaking to you again soon.